All right, so if you do not have any problems, I'm going to just go ahead and do the 5.8 and then just done with our lessons. And after this, we don't have any more lessons. Next Tuesday, you have chapter 5 exams. And the next Wednesday, you have your final exams. And hopefully I can actually maybe a chapter 5 exam, or maybe just make it to be a web assigned homework exam. Instead of doing showing your work, just take your exam and web assign, and when you finish your exam, that you will see your grade. So we can save our time because I need to turn it in all the things by tomorrow. Not tomorrow. Next Wednesday is the last day. So I may just make chapter 5 exam to be not open response problems, but just like your web assigned homework problem, but your submission is only one submission. Since this is exam, whatever you submit, that's going to be your work, your answer, but you don't have to show your work, in other words, okay? So chapter 5 exam, I'm going to be made to be one submission exam, but you don't have to show any work. So if you got right on your exam, your answer is right, then you got it right. Your answer is wrong, then you're wrong. So you don't have to show your work on chapter 5 exam. All right, so let's move on to chapter 5, 5.8. It's inverse trigonometric functions and integrations. The objectives. Integrate functions whose antiderivative involve inverse trigonometric functions. Use the method of a complete the square to integrate a function. And review the basic integration rule involving elementary functions. All right, integral involving inverse trigonometric function. So we learned this one yesterday. Derivative of arcsine is equal to 1 over square root of 1 minus x squared, because your u is x, du is 1. So when you plug it into your formula, the formula says u prime over 1 minus u squared. So you just plug it in u squared, which is x squared, and du is equal to what? 1. That's why you have a 1 here. All right. Same thing over here. We do exactly the same way. So now let's look at the integration. Integrals involving inverse trigonometric functions. Okay, integrals involving inverse trigonometric functions. Now, your derivative of arcsine u was equal to u prime over square root of 1 minus u squared. Right? Now, look at this. Now we replace a. So in this problem, we have a is equal to 1, in other words. But now you can have other than 1 as your a, in other words. So this case, if you have a squared, okay, whatever the constant a is, when you take integral of that, you get arcsine u over a plus c. And this is, again, this is arctangent. Arctangent, the formula says 1 over a times arctangent u over a again, okay? So the problem that we did yesterday, a is equal to 1, but now we can do a that other than 1. It can be 2, it can be 3, whatever, any constant number, okay? So over here, same thing. You're going to have a 1 over a in the front, arcsecant, and this. So you cannot do 5.8 unless you already know how to do 5.7, because we're going inverse of what we did yesterday. So let's look at this one. So looking at this, you need the first thing you got to recognize it is this, what kind of inverse function is this? So this is inverse of what? Arc, this is a arcsine. So we're going to write down, so u squared is equal to x squared, a squared is equal to 4. So which means a equal to 2, which means x is equal to, u is equal to x. So you need to write this down so it's much easier for you. So once you figure that out, so this is your a squared, that's your u squared, okay? So because of because a squared equal to 4, that's why you know a is equal to 2. We're looking at the positive number, okay? And because you know u squared equal to x squared, that's why you know x has to equal to, u has to equal to x. And after that, we just simply plug into our formula. The formula says arcsine x over a plus c. So that's why this 2 came from a, which is over here. square root of 4. Now looking at this, this is arctangent. You need to recognize the pattern. If you're not gonna drive this equation, then you need to memorize, or you need to recognize the pattern. So pattern of arctangent is a squared plus u squared and u prime, okay? That's what it is. So by recognizing that, then you know this is arctangent. So you're gonna say same thing, okay, this is my a square, this is my u square. So that means a squared is equal to 2, then a has to be equal to what? Square root of 2. All right, same thing. Since u squared is equal to 9x squared, how about I write down over here? So u squared is equal to 9x squared. So u has to be equal to square root of 9x squared, which is the same as 3x. Okay, so we just plug it into our formula then. Okay, so we're gonna do our formula, and then don't forget to do u prime. U prime is equal to 3 dx. All right, so let's do it. So if I plug back in, we're gonna plug back in. So u prime, I need 3 times 3x of dx. Since I don't have all right, so since I do not have a 3, so I will put the 3 here and put the 1/3 over here. Because remember, I need the 3 from this derivative of this. U is 3x, so u prime is 3 times dx. All right, so you got this 1/3 that came from this. And 3x, 3 dx, now this can be replaced with the u, du, right? All right, so now after that, we just simply plug into our formula. So our formula says, so the formula is 1 over a, this is your a, and that's your a, that's your u. So just plug into your formula, and that's it.
Yeah.
Then I'm gonna try to.
All right, so does everybody understand where this 3 came from? This 3 came from this. U prime is 3x. So that's why you have to multiply by 3 and divide it by 3 here. All right, next thing. So next one, it looks like, the pattern looks like what? Pattern definitely looks like arcsecant. All right, so you're gonna say, this is my u square, that's my a square. So a squared is equal to 9, so a has to be equal to square root of 9, which is 3. U squared is equal to 4x squared, so u has to be equal to square root of 4x squared, which is 2x. So u prime is equal to just 2 dx. Same thing here. I need a 2, so you multiply this 2 to make u prime. So you multiply by 1/2 in the front. All right, or this case, I need a 2x. But I only have x here, so I can just simply put this 2 in over here. So I don't put it over here, but I put it over there. This 2 came from that 2. Okay? So now I have a u. This is 2x. So I can rewrite this problem as u prime and then u squared minus a squared. And you just plug into your formula. So 1 over a, which is a is 3, 1 over a, and arc secant over a. So you plug it in u, which is 2x, that's your a. So you're done. So you still need to do this, okay? Whenever you do inverse trigonometric function, integral of inverse trigonometric functions, write this down, starting with a squared, watch a, watch u squared, watch u and u prime. If you write down these 5 items, after that you can just plug back into your formula. Okay. Okay, now to complete the square. So complete the square, just think about this one. This is a good example in case you forgot. Whenever you have a trinomials, you can complete that trinomial by complete the square. So what do? The formula says you're only looking at this two, right? X squared plus bx. So you're going to write down x squared bx, and then you're going to add and subtract exactly the same thing. B over 2 minus B over 2 square. You add B over 2 square and minus subtract that over B over 2 square, and then plus C. Then plus C. That when you complete the square, then you get x plus B over 2, okay, which means this will complete the square. Okay, and then the other one, this is left over. This is, so you write down over here. That's just the constant term, okay? So let's practice. So when you have a problems like that, okay, problems like that, you do not know how to take antiderivative of this. Because if I decide to put u to be x squared minus 4x plus 7, and du has to be 2x and plus, excuse me, dx minus 4 dx. But I cannot give 2x minus 4. Remember, I can only multiply or divide a number only. I cannot just supply x, okay? That is not right to do. You cannot, we haven't learned that kind of techniques yet. We cannot do that. So I cannot simply use u substitution. So whenever you have a try three terms, okay, three terms, think about complete the square. So you can use arctangent. So let's complete the square. Then we're gonna write down x squared minus 4x plus 7. We're gonna rewrite this problem as x squared 4x. And then we're gonna add negative 4 divided by 2 square minus exactly same thing. And then plus 7. Okay, so this one is right here. And this is a term that I add and subtract. Just like if I add 2 minus 2, which give you a 0. So I'm not changing problems. So this problem is, then according to the formula, the complete squares, I can rewrite it as x minus, what is it? X minus, so 4 over 2 is the same as negative 2. Is everybody see it? Right? So I can do a negative 2 square. And then the other one, so minus negative 2 square plus 7. All right, so you have, then you're done. So I can complete the square. Square plus 4 plus 7, which is the same as x minus 2 squared plus 13. So let's rewrite this problem. Plus 2, did I not add right? What did I not do right? Oh, it's a subtraction, class. Look at this one. It's a subtraction right here, right? So I need to subtract here. So plus 3. All right, so I have that now. So I can rewrite the problem. After I complete the square, that become a this. Now you can say my u squared is equal to x minus 2 squared. So u is equal to square root of x minus 2 squared, which is the same as x minus 2. And then u prime is just equal to 1 times dx. Next one is a squared is equal to 3. So a is equal to square root of 3. So as I said before, write down this 5 item, u squared, u prime, a squared, and a. Then after that, you can just simply plug into your formula. The formula says 1 over a arctangent u over a plus c. So you're going to put the a, which is square root of 3, u, which is x minus 2, and a right here. Just plug into your formula. All right. So next one, just the basics, the review of the basics. Okay, review of the basic integration rules. So as you know, all these things you already have learned, so go over this. So again, when you take your final exams, this is probably a good one to print out to refer to, because this one has all the integration rules. And here's more. All right, so you know how to do it. All right, this is the last one. Let's look at this problem and see whether we can do these problems by applying the knowledge that we already have learned, okay? So look at letter A. Do you know how to take antiderivative over this? What does it look like? This looks very similar to which one? Arcsecant, right? So you're gonna say, okay, I can say u, this is u squared, this is a squared. So I'm gonna say u squared is equal to x squared. That means u is equal to x. A squared is equal to 1, so a is equal to 1, and u prime is equal to just dx. All right, so I can say, okay, then I know how to take antiderivative over this. So this is just simply just to 1 over a arc secant u over a plus c. So I'm going to just plug it in. So my 1 over a is 1, so 1 over 1 arc secant u is x plus 1 plus c, or just simply arc secant x plus c. So I'm done. Yes, you know how to do it. Now let's look at the second one. Do I know how to do this problem? Okay, this case, since x is in the numerator, I am not going to use any of this the inverse trigonometric functions. This is just simply u substitution problem. So this case, you're gonna say, okay, my u is equal to x squared minus 1. So du is equal to 2x dx. So you're going to say, okay, I need to put 2 in the front. I need to put the 1/2 in the front. Then I'm pretty much done. So I can rewrite this problem as 1/2 u to the 1/2, negative 1/2 du. And then you just finish this one up. So you have your 1/4 u to the 1/2 plus c, and then plug back in your u, which is so you're done. All right. Okay, the last one. The last one, you cannot do this problem. We have not learned these techniques because this is not the form, the pattern that you can recognize. We do know this. All right, that case, it is arcsine. All right, but this is x squared minus 1, which we have not learned. So we don't know how to do this problem. So we know how to do this by using our inverse trigonometric function. We know how to do this by doing a u substitution. But this, we don't know how to do it. Okay, so that's what it is. Oh, excuse me. 1/2 and 1/2 cancel out, so we don't have anything. Sorry. All right, so that's it. That's it for the lesson wise. Anybody have any questions from today's lesson that you want me to go over? Like, do you want me to go over the complete the square again, or anybody have any questions? Is everybody comfortable with the completing the squares or pattern recognitions? All right, so let's go over a few problems. All right, guys, this is our last homework problem. Okay, so this problem, you guys need to recognize which one is the one that you're going to use as a trigonometry function, or which one you're going to use as a u substitution. So this problem, let me give you a hint. So you have x to the third and you have x squared. So that is your hint that you're going to use u substitution instead of inverse trigonometry functions. So this case, you're going to say my u is equal to x to the third plus 8x. U du is equal to 3x squared plus 8 and dx. All right, so I can rewrite this problem as 1 over u du. In other words, that's just natural log. So that's it. That's why your answer is equal to natural log u plus c. And you just plug it in your u, which is 3x squared plus 8x plus c. By the way, they put this square root, you don't need it, right? Because square and square is what? They cancel out. So I have no idea why they put it. So the best thing is just put the absolute value. Okay, just put the absolute value. Because if you put the absolute value, so what they did here, x to 3 plus 8x squared, this is equivalent to x to the 3 plus 8x. The absolute value, they're saying, because anything to square become a what? Positive. All right, next one, the derivative of function, you can do that. Evaluate the limit. L'Hopital's rule. So hold on, see, is this am I not looking at the right problem? Oops, goodness. I was looking at the wrong one. Oh my gosh. All right, I'm gonna make my exam 8 differently. The one that I just showed you, that is not gonna be on your exam. Okay, sorry, I made a mistake. All right, let's look at the lesson 8. Goodness. I am not doing my work right now, right? Okay, so let's look at this one. Find the indefinite integral. So you need to recognize this pattern. The pattern is what? Arc sine. And whenever you do problems, you need to recognize it. You need to do your homework problem so you can recognize it. So you're gonna say a squared is equal to 9. So a is equal to square root of 9, which is 3. U squared is equal to x squared. So u is equal to square root of x squared, which is x. U prime is equal to 1 times dx. Then you just plug into your formula. Since it's arc sine, it's gonna be what? Arc sine u over a plus c. So arc sine u is x over 3 plus c, and you're done. So make sure you do this part right here. This is how you can do your problem right and put it into your formula. All right, so this one definitely looks like what? Arcsecant. So I know this pattern has to be equal to 1 over a arcsecant u over a plus c. That's the pattern that I'm going to use. So now let's just write it down, what we know. So you're going to say, okay, u squared is equal to 16x squared. So u is equal to square root of 16x squared, which is 4x. U prime is equal to 4 dx. A squared, that's a. So a squared is equal to a, so a is equal to just 1. A squared is 1, so a is 1. So I'm just plugging it into this. Now I'm going to recognize this. I need 4 times dx, but I don't have a 4. So I multiply by 4 here and divide it by 4 there. All right, after that, I'm just plugging into my formula. So 1/4, my a is 1, so 1 over 1. Arcsecant u 4x over 1 plus c. So that's it. Okay, so actually this 4, here's one. This 4, I need to put this in over here because the x has to be what? The u is equal to 4x. I don't have a 4. So put the 4 over here instead of over there. That means I don't have this. So your answer is just the arc secant 4x plus c. Remember, u has to be equal to 4x, but I only have x, so I need to supply 4. So supply 4 in the numerator, supply 4 in the denominator, so you're not changing your problem because 4 over 4 is equal to 1. All right, so let's practice this one. This is complete the square. So you can recognize right away, this is arctangent. So my answer should be 1 over a arctangent u over a plus c. Right? That's the answer it should be. So now I got to complete the square. So let's rewrite it. So 1 plus 4x squared, I can rewrite it as, let's rewrite it as 4x squared. So I don't have a middle term, so you just need to take a square root like this. So that's what you have to do. So 4x squared, you got a 0x plus 1, right? And then you're gonna tell yourself, okay, I don't have anything. So if I rewrite this problem, so I'm gonna do like I usually do, complete the square. So I'm gonna do 4x squared plus 0x, and then I'm gonna add and subtract. Add 0 over 2 squared minus what? 0 over 2 squared. Right? And then you're gonna do, okay, I'm gonna do the same thing, and then I will add 1. But as you know, this is equal to what? Whole thing over here, if I complete that, I just have a what then? 2x. And in other words, I just have 2x, okay? 2x squared. And then if I do this one, I have plus 1. Well, actually, this, I don't even have to complete the square because I only have 2 terms. Excuse me, I made a mistake. I don't have to do any of this, right? Because I only have 2 terms. I do complete the square whenever I have what? 3 terms. So this is only 2 terms. I don't have to do anything. I just need to simply recognize what is my a and what is my u. So this is my a, this is my u squared. So u squared is equal to 4x squared. So u is equal to square root of 4x squared. So u is equal to just 2x. A squared is equal to 1, so a is equal to 1. Oh, I forgot to find u prime. So u prime is equal to 2x, 2dx. All right, so I'm just gonna do everything what I need. So I'm gonna, let's just put 18 here. And then we're gonna multiply this, which is 2, and divide it by 2. All right, so then I can just plug into my formula. So I have 18 divided by 2 is just happen to be just a 9. So I can rewrite it as 9 times 1 over a. A is equal to 1. Arctangent, u is 2x, 1 plus c, which is equal to 9. Arctangent, 2x plus 1. All right. So I think I did everything pretty much the examples you need to do. Let me see, is there something that you need to do, complete the square? If you do have a complete the square, I want to go over one more time. But it looks like I didn't give you any problem that you have to complete the square. Okay, so you don't have to worry about the complete the square because I didn't give you any problems like that. All right, any homework problems that you want me to go over? Is everybody good? Any questions?
Ms. Harris.
Yeah. Yeah, do you have a question for me?
I have a question to you about the final.
Yes.
Um, You said that that you gonna pick questions from the review.
Yes. Our
You-
problem from your review.
okay. And
So,
all the homework assignments due next Monday at 5.
go ahead. What was your question?
I said all the homework is due by
Monday.
next Monday, or we can still extend it to at least until the 25th.
Probably I wanted to finish by a. See, I'm planning to turn it in your grade on 25th after your exam.
Okay.
Maybe I can give you one more day for 24th, but not 25th. Because if you do
Okay. Okay. That's all. That's all I want to ask you.
24, so our extended everybody's homework to 24. How about that? Okay.
Yes, ma'am. Thank you.
In chapter 5 exam, I am not going to make open response problem. So the chapter 5 exam would be just a regular problem, which means you write down your answers in your web assign. So if your answer is right, you get correct. If answer is wrong, you get incorrect. So you get your score right away because it's not going to be open response problem. I'm not going to have time to grade your paper and then also the finals. It's not enough time. So the last exam, I'm going to make it to be a regular exam, not open response.
Okay. Thank you, Ms. Harris.
All right. So you guys, I will see you next Tuesday. Please finish all your review problems and I'll see you next Tuesday. All right. Okay. Talk to you later. Goodbye.